In this video, we're going to be talking about matrix notation and really how matrix notation works in Excel because it's a little bit different than your typical matrix notation. So first, we'll give a brief overview of what matrix notation is. Matrix notation is used in linear algebra and when solving systems of equations. And it's used as kind of like a shorthand method of describing different sets of data. The first type of matrix notation you might encounter is a vector, which can mean a single line of data, either in the vertical or horizontal direction. Vectors are usually represented by lowercase letters to show that they are vectors, and they're usually encased in brackets. So if we look at the examples, here we have B, which is a lowercase letter, indicating that this is a vector of the numbers 1, 3, and 2. Conversely, we can also write this vector in the vertical direction, where we have x, again as a lowercase, showing that it's a vector of the numbers 1, 2, and 3. So these are essentially just lines of numbers, although vectors can also have lines of other types of data, so it could be letters or even words. Now, then there's also matrices, which is plural for matrix, and a matrix consists of two or more parallel vectors of data. So they're either going to be two vectors in the vertical direction or in the horizontal direction. Again, they're often encased in brackets. Matrices are sometimes called arrays. That's usually more so in programming culture, which uses a lot of matrix notation. So you may hear them used interchangeably, matrix and array. And matrices are usually denoted by an uppercase letter to show that they are a matrix and not a vector. So we have some examples here. Uppercase A shows a matrix of these 6 data points, or uppercase Y shows a matrix of these 9 data points. So matrices really are how your data is often displayed. If you are collecting different types of data, such as like weight, height, time, those will probably either be in the columns, representing the different columns, and then different samples like sample 1, sample 2, sample 3 might represent the different rows. So looking at matrix A, there's 2 columns, so maybe the first column on the left is the time, and the column on the right is the weight, and then the first row would be the first sample, the second row would be the second sample, the third row would be the third sample, and so on. So really, without even realizing it, you may have been using matrices already if you've taken another statistics class or another math class or just any sort of data analysis class. It's important that you can move within matrices and you know how to call out or identify the rows or the individual datum that you want to manipulate. Matrices are laid out in a row-column system. So rows are essentially the horizontal vectors and the columns are essentially the vertical vectors. And there's a very standard way that you identify specific datum within a matrices or matrix. So the first number located in the parentheses being that one specific datum point, is going to be the row, and these followed by a comma, and then the second number is going to be the column. So if you look at the example on the left, that first datum in the upper left-hand corner is 1 for being in the first row, the row at the top, and also 1 for being in the first column, the column on the left. If you move to the datum below it, you can see that it's a 2 followed by a 1. This is because it is now in the second row, but also still the first column. If you go to the bottom right-hand side of that example, you can see that it's a 2 because it's again in the second row, the second row from the top, and also the second column from the left. So 2, 2 in this instance. You can also use this numbering system to identify datum or specific locations within vectors, as the example on the right shows. In that instance, when you're using a vector, it's just there's only going to be either one column or one row. So one of the numbers will always be constant. Now let's talk about matrix notation in Excel, because Excel is a little bit different. Excel, instead of using a number system, it uses a letter number system without the comma in the middle. So all of the columns in Excel are shown by having letters, and all the numbers in Excel are shown by having, or all of the columns in Excel have letters to represent them, and all the rows in Excel have numbers to represent them. And the column always comes first. So if we take a look at an Excel spreadsheet, we can see up here that we have the letters A, B, C, D, and so on representing the different columns. And then we have numbers 1, 2, 3, 4, and so on representing all of the different rows. And if we're going to click on an individual cell, this cell would be represented by the column A and the row 2. So this would be A2. If we click on the one next to it, this would be represented by column B, row 2. So this would be B2. So as you can see in this example on the left, this matrix, it's just what I showed you, the upper left-hand column, that's the very first cell in an Excel worksheet, would be A1. The cell below it would be A2. The cell to the right of the most upper left cell would be B1, and so on. So you can call specific cells within Excel. Now, at times you may want to subset matrices in Excel. This just means that you want to pull out specific parts of a matrix in Excel. So maybe you want to call out just the first row, or maybe you want to call out just the first column, or maybe you want to identify just the first cell. There are specific ways of doing this, often using the colon. So if you look at the example of the first row is denoted by the number 1. You would say, I want row 1 to row 1. So the colon essentially means 2. Since you just want row 1, you put that notation there. If you want to call out the first column, you put in, again, the first column is shown by, or denoted by the capital letter A. So you put in equals A colon A. So I want all of column A to column A, just column A to infinity. If you wanted that first cell in the upper left-hand corner, you would put in the information for just that cell, which would be equal to A1. So let me show you what this looks like in Excel. So I'm just going to put my information here. So let's say that I want to highlight the first row of my data, which is actually row 2. I would put in equals 2 colon 2, and we can see that it highlights just that specific row. So if all I want is just the data in that row, I can easily access it this way. What if I want just the data in column B? So I just want the height data. Well, then I can do the same thing, but with B. So I put in capital B colon capital B. You can see that it highlights just the column of B. Now what if I want that first data point, that date, January 5th, 2004. Well, then I'm going to put in the information with the column first, followed by the row for that date, which would be A2. And you can see that it highlights that specific column. Now, what if I want to highlight this entire matrix of data? We can see here I have this example, again, with the locations shown in the matrix, that I'm going to denote that by putting first the most upper left-hand cell that contains the matrix, and then the colon to the most lower right-hand cell, which would be C2 in this example. Looking back at an actual example in Excel, if I want to highlight just all of the data in here, that would be A2 equals A2 to B7. And that highlights all of the data in that selection. So we want to think about copying formulas. Sometimes if you arrange your data correctly in Excel, you should always think about how your data is arranged to optimize copying and pasting, so you don't have to type in the same formula 50 times. You can type it in once and then copy and paste it down or to the right. You'll often be copying and pasting formulas or equations that call out data in specific cells. When you copy and paste a formula, it is copying and pasting the formula. It does not also automatically copy and paste the cell location of the data you're calling out. So if you want to always specifically call out a specific row or a specific column in your equation or a specific cell, you need to add in a little bit of extra information into your formula. And Excel does this actually pretty cleverly by using the dollar symbol, which doesn't have any mathematical meaning independently. So since it's on your keyboard, they decided to utilize it this way. So you can use the dollar symbol to indicate what, if the column or the row, or the column and the row should always be the same when you're copying and pasting, when you're referencing. So let me show you what this kind of means. So let's say that we have this selection that we're going to use, and let's say that we want that first set of data in the upper left-hand corner, so that's going to be equal to A2. Okay, so now we can see that it has that same set of data, January 5th, 2004. So let's go to that data and let's copy and paste it down. We can see that it's now changed. It's not still referencing that same cell. That's because we just copied and pasted the formula, which is just equal. So it's just showing whatever is in that cell. So since I copied and pasted it down, it is now showing the data in the cell below it. So that's March 28th, 2004. What would happen if I copied this formula again and pasted it to the right? Well, now it's just giving me a weird answer because Excel thinks this is the date and it's now referencing the cell to the right of it. So even if we go hover over it, you can look up in the formula bar at the top that it's now referencing B2. So sometimes this can be very useful when you want to copy and paste just the formula, but what if you want just that data point? Let's take a look at that. We're going to have to redo this. So if you want Excel to always reference row 2, so the column can change, it can go from A to B to C, but you always want it referencing O2 or row 2. What we're going to do is we're going to put in the equal sign. We're going to first reference that first cell of data, A2. We're going to put in A, so the column can change, and then we're going to put in that dollar sign to show, but we always want row 2 to be referenced. So we got $2. Now if I copy and paste down, it's still referencing that same data because it's staying in the same row. And if we copy it again and paste it to the right, we can see that the data changes because the column can change, so now it's referencing B2, but it's ensuring that the row always stays the same. So you can do this also for making sure the column stays the same. You would just put the dollar sign in front of the column instead of the row. What if we always want to reference that first date, January 5th, 2004? Well, we can make sure that that cell is always referenced by putting a dollar sign both in front of the column and in front of the row. So now at this point, since I've got that dollar sign in front of both the column and the row, I can copy it and I can paste it literally anywhere on this spreadsheet, and it will always be the same because it's referencing specifically that cell of A2. So sometimes you have a variable or a constant in a formula that you always want it to reference that specific cell. This is an easy way to do that. And I would encourage you to play around with this to make sure that you really understand how copying and pasting in Excel work and how that dollar sign can be used when copying and pasting to make sure that specific cells or rows or columns are always referenced. So in summary, vectors and matrices are useful frameworks for thinking about how data is arranged. It kind of gives us a way to think cohesively about this data instead of it's just there with random organization. It's not. There is a specific way it's arranged. In standard matrix notation, using linear algebra or most software systems or other statistics packages like R, it's denoted first by the row and then the column. when you're calling out a specific location in a matrix. However, in Excel, it's a little bit different, and it's denoted, location is denoted by the column, which is a letter, and then the row, which is a number. The use of the dollar sign will make sure that you're always referencing the cells that you want, especially if you want some referencing to stay the same. And unfortunately, I'm not going to talk about linear algebra and all of the different calculations you can use, which uses systems of equations. But that's when matrix notation really shines, because it makes mathematical computations a lot easier to write down and to think about. So matrix notation goes well beyond what's discussed in this lecture, but it can still be useful when we're thinking about simple ways that we organize data.